Alright, today we're going to solve the Leetcode question 21 called Merge two sorted lists. Consider easy problem, and the type of this problem is a singly linked list. So this question is often asked by a lot of companies, so it's better for us to understand the gist of this concept. So let's read the question. Merge two sorted linked lists and return it as a sorted list. The list should be made by splicing together the nodes of the first two lists. So as we see in this example, if the first list is constructed of 1, 2, 4 and the second comprises of 1, 3, 4, then we have to generate a new linked list that sort of contains the elements that is sorted completely. Logically, we can tell that we have to compare the first and second and third, whatever the corresponding placement of indices and elements, then we have to generate a new linked list. So we definitely first have an idea that, let me write quickly a pseudocode. First, we need to generate an empty linked list, or I can declare, right? And second is compare each indices values from L1 and L2, means list 1 and list 2. And what we want to do is populate or append the smaller values into the empty linked list. Right? Empty linked list, I'm sorry. So, and then last of all, we have to return that linked list. So everything here is about the pointer idea. Actually, for example, what I'm saying is, let's say if we declare that as a result is list node, this is how we instantiate a new empty linked list, as you see above here. But this result serves purposes of adding linked list by traversing through the next. So this result's gonna keep tracking of every new element that is added to the array. So by the time we finish the loop or our calculation, the pointer of this result is gonna definitely refer to the last element of this node. So how can we return the general list? We cannot go back, or we cannot do anything else. That's why we want to generate a new sort of a dummy node, or you can say a head node like this, meaning you can write something like this, or you can just write like this as one line over here. So what this does is, okay, I'm going to declare two list node, but this is having the same address of list node. So this head is still refers to result, unless we're not updating this head location by putting .next method. So I'm gonna tell you what this means. So we are gonna definitely need iterator. Next step is a loop, because we need to traverse through the H element. So in this condition, we have to decide whether we need to use for or while loop. In this case, I think while loop is more appropriate, because while loop ends when certain specific condition is satisfied or end, right? So I can say while L1 and L2, meaning while there's something left in L1 or L2, that we have to compare if L1.value is smaller than LU.value, because that's what we need. This is the moment we should do the value comparison, right? And we should append the smaller values into the empty linked list. So let's append a smaller one over here. Okay. So what we can do is I can say result dot next equals L1, and after we append or link the new value of result to L1, we have to increment L1 by putting L1.next. Usually, if this is not a linked list, we just L1 plus plus or plus equal 1 or something, right, in Python. But since this is a linked list, we say L1 equals L1.next. What this does is it's going to move the L1 pointer to the next element of L1. Next is the opposite case of else, meaning what this means is L2 val is smaller than L1 val, right? What we want to do over here is we want to dot next, we want to link it's the next value to L2, right? L2 is a whole list node, also L1. It has a value and a pointer to the next. Okay, so we have to move the L2 equals L2 dot next. This step is very necessary. Please don't forget it. A lot of people say, okay, I just hooked up the result node to the L1 and L2 and that's it. However, no. If you don't manually put these lines, L1 equal L1 next, the pointer is not going to move. So this is very important. Let's think about the next step. This is actually that we have one remaining step. Now, I understand that we hooked up L1, result dot next equals L1, so we are keep sort of hooking up, but we are not updating its pointer. So we have to update result equals result dot next by putting this line, meaning, okay, I understand that we are appending new values at the very end, but at the same time we have to traverse through, we have to move the results, kind of the next ideas by putting the next indices or next pointer as a reference, you know. You get the idea, right? So after adding a value, we are moving the L1 of each corresponding, as you see in this picture. And if it's L2 smaller, we're going to do L2 and I'm going to put it on. And after we add it, we may assume automatically, okay, because we put next, maybe the result pointer is automatically knows that we're updating. No, actually not. After we do whatever time, we have to physically move the result pointer. And let's think about, we finished. So this is sort of the end, but at the last minute, we have a case that we still have a remaining or residual values, right, after we finish them. So there might be a case that if L1 is remaining, and there's L2 is remaining. If L1 is remaining, is we want to result dot next equals L1 still. That's what we want to do. Okay. And if L2 is remaining, then we have to append L2 over here. Okay. And the last but not least, we have to return the whole array. How do we do this? This is where our initial, the head pointer or dummy pointer kicks in. Now, the result pointer, as you can see, is referring or it's to the last element of this array, right? Because we keep incrementing it to just appending it, right? But head pointer is still referring to the very first part of the node because we haven't incremented yet. So if we say head.next, then it's going to refer to the whole general array that were just generated because it still gives the reference to the same address as result. Okay, so this is sort of the idea. So let's run it. I think I've explained pretty thoroughly, step by step. So runtime error, expected indentation. We need to indent these, right? Okay. But not this one, because this one's gonna result equal result dot next. We have to execute it every time it goes through the inside the while loop. Okay, that accepted, and pretty sure it'll accept it as well. That's it. So I hope you understand this logic, and if you have any questions, feel free to leave any comments. Thank you. Have a great day, my friend.